Today we talk about sum and difference identities or sum and difference formulas, however you want to talk about it. These are used to find trigonometric values, exact trigonometric values for sine, cosine, secant, cosecant, cotangent of any non-unit circle angle that is made up of a sum or difference of two known unit circle values. And the known unit circle values we know are the 30, 45, 60-degree multiples, 90s obviously. So in this case, we see we're asked to find a sine of 75 degrees. Now, we don't know what the value of 75 degrees is on the unit circle, but we can say that 75 degrees is made up of two angles that we know about, 30 and 45. Unfortunately, sine is not a number, so we can't multiply it in and say, well, that's just the sine of 30 plus the sine of 45. That's a no-go, and please try to get rid of that idea altogether. So we have these formulas for each of the three values, sine, cosine, and tangent, and here they are. And notice the correspondence here. We have the sine of some x plus y value as well as the sine of some x minus y value. It's a dual correspondence. It's equal to the sine of the first value, the cosine of the second value, plus the cosine of the first value times the sine of the second value. And then likewise, if it's a difference, we have the sine of the first value minus the second value is equal to the sine of the first value, the cosine of the second value minus the cosine of the first value, sine of the second value. Sine, cosine, cosine, sine. Now, the cosine one is a bit trickier only because its correspondence is turned upside down. You'll notice that we have cosine of some value plus another value is equal to the cosine of the first value, cosine of the second value minus, notice the correspondence, plus goes to minus in this case, sine of the first value, sine of the second value. Likewise, opposite correspondence here. Cosine of the difference of two angles is equal to the cosine of the first, cosine of the second, plus the sine of the first value, sine of the second value. Finally, tangent. You'll notice, look at the correspondence is flip in this case. Tangent of the first value plus tangent of the second value over 1 minus, there's the flipping correspondence, tangent of the first value times tangent of the second. Unfortunately, you're going to have to memorize these. Proving them is kind of a pain, and you wouldn't get much out of it anyways as far as being able to carry it forward, so I'm not going to show you that. So just know these sum and difference formulas and be able to apply them, and we'll go through and apply a lot of these concepts right now. So we're going to actually find the sine of 75 degrees, and the sine of 75 degrees, like we said earlier, is the sine of 30 degrees plus 45 degrees. So I use my sine identity, which is sine 30 cosine 45 plus cosine 30 sine 45. These are all known values. Sine of 30 degrees is a half. Cosine of 45 is root 2 over 2 plus root 3 over 2 times root 2 over 2, we get root 2 over 4 plus root 6 over 4, which gives me root 2 plus root 6 over 4. And that's your exact value of the sine of 75 degrees. So in this case, I have the cosine of 13 pi over 12, which we have no idea where that is. And probably, until you're used to it, seeing a lot of these, it might be easier to actually convert these to degrees. So if I wanted to convert 13 pi over 12 to degrees, which I normally wouldn't do, but adding radian values is a little bit more difficult. Again, we multiply by 180, divide by pi, and that gets us about 195 degrees. Which I know is, let's see, 195, probably 150 plus 45 is the easiest way to do that. So what we're looking for is the cosine of 150 plus 45 in this case. So that's the cosine of 150, cosine 45. Opposite correspondence, minus cosine, minus the sine of 150 times the sine of 45. Cosine of 150 degrees is negative root 3 over 2. Cosine of 45 degrees is root 2 over 2. Minus sine of 150 degrees, a half. Sine of 45 degrees, root 2 over 2. So I have a negative root 6 minus root 2 over 4 on this. You could rewrite that, say it's the negative of root 6 plus root 2 over 4. Either way would work. So in this problem, we have the tangent of 285 degrees. And quite frankly, I don't think of two angles that multiply or that add to 285 very easily. I see 285 as an angle down in the fourth quadrant, 75 degrees away from the nearest x-axis, which means its tangent value will be the same as the tangent value of 75 degrees. However, since it's in the fourth quadrant, it'll be opposite. So I prefer to think of tangent of 285 as the opposite of tangent of 75. Now, if you can think of two angles that add to 285 in your head quickly, knock yourself out. This is just an alternate way of solving it. So this is going to be the opposite of the tangent of 30 plus 45 degrees, which gives us the opposite of tan 30 plus the tan 45 over 1 minus tan of 30 times the tan of 45. We'll see why this gets messy in a minute here. Tan of 30, that's the y value, which is a half over root 3 over 2. Half over root 3 over 2 is 1 over root 3, which is root 3 over 3, plus tangent of 45, that's just root 2 over root 2, which is 1, over 1 minus root 3 over 3 times 1. So you'll see we have this complex fraction multiplied by 3 over 3 to clean it up a little bit. That gives me root 3 plus 3 over 3 minus root 3. Let's keep in mind all this is the opposite. So now if I'm going to clean this up, I have to rationalize by the conjugate. So this is 3 plus root 3, 3 plus root 3, and I end up with, I'm going to FOIL that out, I get, let's see, 3 root 3 plus 3 plus 9 plus 3 root 3 over 9 minus 3, which is equal to 12 plus 6 root 3 over 6. And we're keeping in mind once again that all these are the opposite. So if I factor out a 6, I have the opposite of 6 times 2 plus root 3 over 6. 6's go, so this is the opposite of 2 plus root 3. Tangents are messy. That's all there is to it. Alright, now we want to find the exact value of this function. This looks like a total mess. However, we notice this is an identity. This is, or a formula, or what have you. So cosine, cosine, sine, sine. And cosine, cosine, sine, sine is the cosine of a sum and difference. So since we notice that this middle term is a subtraction and we have an opposite correspondence, this is the sum of cosine identities. So this is really the cosine of 13 pi over 24 plus pi over 8. So if I know what that value is, I'm gold. I've got the cosine of 13 pi over 24 plus 3 pi over 24, which is the cosine of 16 pi over 24. Luckily that reduces, 8 goes into both, so it's the cosine of 2 pi over 3. And I know the cosine of 2 pi over 3 because cosine of 2 pi over 3 is just this guy right here, and that's equal to negative 1/2. So we've got to start recognizing whether we have a sum and difference of sine, cosine, or tangent value now. Next we have a verification problem. Again, be very careful not to distribute sine because sine is not a value, it's a function. So we have to expand this identity. Sine identity is sine, cosine, cosine, sine. So I have sine of 3 pi over 2 cosine of x. Now the sign correspondence is exact, so it goes minus to minus. It's not opposite. So sine, cosine, I need the cosine of 3 pi over 2 and the sine of x. And hopefully that equals the opposite of cosine. Well, the sine of 3 pi over 2 is negative 1 times cosine x. That's not a bad thing. Minus the cosine of 3 pi over 2 is 0 times sine of x. This term goes away. I'm left with negative cosine of x, which is exactly what I wanted. Another verification, you've got to show that this quantity is equivalent to cosine of y. We've got an expansion to do. Now notice this cosine here is a multiplication. This sine here is a multiplication. So we're going to have to multiply that into whatever we get after we expand these sum and difference identities. So the cosine of x plus y, that's cosine, cosine, sine, sine, opposite correspondence. So cosine of x, cosine of y, minus sine of x, sine of y, and all that's going to get multiplied by the cosine of x. This is sine of x plus y, which is sine, cosine, cosine, sine, sine of x, cosine of y, plus cosine of x, sine of y, and all of that is multiplied by the sine of x. And we hope that equals our cosine of y. I'm going to distribute through, so I get cosine squared of x, cosine of y, minus sine x, cosine x, sine y, plus sine squared of x, cosine y, plus sine x, cosine x, sine y. Luckily, these two terms go away, which leaves me with cosine squared of x, cosine y, plus sine squared of x, cosine y. We're fortunate. Cosine of y is in common, so I'll factor that. I get a cosine squared of x plus sine squared of x. We're starting to get real happy. This is just 1. We know that to be a Pythagorean identity. So I'm left with cosine of y, which, what do you know? That's exactly what we want. We got a few more. Okay. We're given that the sine of x has a value of negative 5/13, and it happens to be in the third quadrant. And we're given that the cosecant of y is root 10 over 3, and that's going to be in the second quadrant, and we want to find the cosine of x minus y. Again, we cannot distribute the cosine. Let's just expand this into its proper formula. Cosine, cosine, sine, sine, and the opposite correspondence. So cosine x, cosine y, plus sine x, sine y. Now, notice we have cosecant here, so the sine of y is going to equal 3 over root 10. And we're going to start plugging things in as soon as we find our other values. We know that this is a triangle. Here's my angle x, and that's equal to 5 over 13. Since that's a perfect triple, we have 12 as our other value, so we know that sine of x equals negative 5/13, and the cosine of x is equal to negative 12/13, once again because it's in the third quadrant. Then I have another triangle of y being our angle, and we know that in this case root 10 is our hypotenuse and 3 is our opposite. So I have 1, and we can get that from 10 equals 3 squared plus x squared. We get 1. So we know that our sine, in this case, since we're in the second quadrant, is equal to, this is sine of y, is equal to 3 over root 10, and our cosine is equal to negative 1 over root 10. And now we plug into this formula. We need the cosine of x, which is negative 12 over 13 times negative 1 over root 10 plus the sine of x, which is negative 5 over 13, and the sine of y, which is 3 over root 10. You'll notice in both these cases we have a common denominator. This is 12 over 13 root 10 plus negative 15 over 13 root 10, which is negative 3 over 13 root 10. Can't let that root 10 on the bottom go, so we'll rationalize. It's negative 3 root 10 over 130. And we're good to go. So these problems, once again, break down into two triangles. Here's a different look at the same problem. We're asked to find two inverse values of which we don't necessarily know that if they're exact unit circle problems. In fact, the second one, the sine of, or the arc sine of 12 over 13 isn't a unit circle value. This guy very well might be, but you may not know it right off the bat. So what I'm going to tell you is this. This is going to lead us to some angle. Let's call this angle x. And this is going to lead us to some angle, let's call it y. So what we're going to do is say x is equal to the arctan of root 3, and y is equal to the arcsine of 12 over 13. And so if that's the case, what we're really looking for is the cosine of some x minus y value, which we know is the cosine of x, cosine of y, plus sine of x, sine of y. So if we can find the cosine of x, cosine of y, and the sine of x and the sine of y, we're good to go. We know in this case that the tan of x is equal to root 3, and in this case the sine of y is equal to 12/13. From each of these I can construct a triangle. in each case, we know the following. We know that we have an opposite and an adjacent given the tangent. All we have to do is find the hypotenuse. So that's 1 plus root 3 squared equals the hypotenuse squared. So we know that this is 4 equals the hypotenuse squared. So 2 is equal to my hypotenuse. Therefore, the sine of x is equal to root 3 over 2. And the cosine of x is equal to a half. In this case, Pythagorean triple. So I have the sine of y equaling 12/13, which we already knew, but the cosine of y is equal to 5/13. And now we can just plug into our formula over here. Take the cosine of x, which is a half, cosine of y, which is 5/13, and add that to the sine of x, which is root 3 over 2, and the sine of y, which is 12/13. I get 5/26 plus 12 root 3 over 26 is equal to 5 plus 12 root 3 over 26. So once again, this ends up being a two triangle type problem, but you have to state that the inverse of one value is going to be one angle, call it x. The inverse of another value is going to be another angle, call it y, and then you end up with the sum of difference identity. And that's all we've got. So fill out this summary form and do your My Math Lab, and we'll see you tomorrow. Take care.